All right, so this is going to be the review sheet for the quiz for tomorrow. And definitely use your calculator. That's probably really helpful. So the idea is for this particular quadratic, what we're going to do is write the equation of the axis of symmetry. Don't forget that the axis of symmetry is the equation x equals negative b over 2a. You're going to have to write the coordinates of the vertex. Remember, the vertex is always an ordered pair in the form of x comma y. Determine whether the vertex is a maximum or minimum, and then state the domain and the range. So for this first particular one, we'll do everything algebraically first, and then we'll show you in the calculator how you can double check it. But if you look at the quadratic, and remember, quadratics are always in the standard form of y equals ax squared plus bx plus c. In number one, the a term is 1. That's what's attached to x squared. The b term is negative 10. The axis of symmetry is x equals, you might as well put the x equals over here first, equals the negative of b over 2 times a. Well, we know b is negative 10. We know a is positive 1. So when we do the math, we end up getting 10 over 2, or the axis of symmetry is just x equals 5. In order to find the vertex, and what we need to do is plug in that x value in the axis of symmetry into the equation that's given. So the equation that you are given is y equals x squared minus 10x plus 13. Well, we know that the x value is a 5. If we do the math, 5 squared comes out to be 25. Minus 10 times 5 is minus 50 plus 13. When you keep going, you get negative 25 plus 13. And when you finally finish everything, you get y to be negative 12. So your vertex then is the ordered pair. I'm going to come back up here of the x coordinate, which was 5, and the y coordinate, negative 12. Max or min? You should be able to look at the equation and say, well, the fact that the x squared term is a positive one, then I know that this parabola is going to open up, which means I'm going to have a minimum. You should also know that the domain never changes. It's always an equation. And the equation is domain is x can be any real number you want. X equals the reals. The range has everything to do with the y coordinate of the vertex and whether you have a min or a max. The fact that you have a min, remember your parabola is going to go this way. So you know that the y coordinate is going to be greater than or equal to whatever the lowest y value is. Well, your lowest y value is that number in your range, or negative 12. So here's everything for you. The axis of symmetry, your vertex, it's a min. Domain is always the reals for the x's, and the range is y is greater than or equal to negative 12. The question is, well, can you verify this or back it up on the calculator? And here's where you can. On the calculator, if you go to y equals, let's try that again. If you go to y equals and you type in x squared minus 10x plus 13, and you go to your graph, you're going to see a parabola that opens up. You're not going to see the vertex because remember the vertex dropped down pretty low. The vertex is somewhere down here. But if you take a look to where the turning point looks like it would be, it looks like it's going to be somewhere through here as the fold over. And by the way, you can count over 1, 2, 3, 4, 5. And that is what the x coordinate of the vertex was. You should be able to see the table of values right here. As I go to the table of values and I start scrolling through and I try to find 5 on my x value, which is right here. I'm actually going to line this thing up though. Wrong way. Let's try this again. I'm going the wrong way. There we go. Okay. So when I go and I line up my vertex in the middle, you can see where here's my 5 and my negative 12. But on either side of that vertex symmetrical. Negative 11 to negative 11, negative 8, negative 8, negative 3, negative 3. So for sure, the vertex that I found is 5, negative 12. That's what I'm seeing down here. The axis of symmetry, again, is the number that goes through that x coordinate, and your range all depends on your y value. The y value you know is negative 12, and all the numbers on the either side of negative 12 are greater than or equal to it. Okay, so if we kind of go back to what we did here, make sure you're good with this particular piece. Axis symmetry, x equals 5, vertex 5, negative 12. It's a minimum, it opens up. Domain is always going to be x equals the reals. And the fact that it's a minimum, y is greater than or equal to the y coordinate of the vertex, which is also negative 12. Okay, take a look at this one. Axis of symmetry. We know that the a value this time is negative 1. The b value this time is 8. X equals negative b over twice a. Well, we know that b is a positive 8, a is a negative 1. When we do the math, negative 8 divided by negative 2 is just equal to 4. So the axis of symmetry is x equals 4. Vertex. Y equals negative x squared plus 8x minus 6. I'm sticking in the 4 for x. When I do the math, watch out for the order of operations. I've got to square 4 for 16, bring down the negative, plus 32 minus 6. When I do the math here, I get y equals 16 minus 6, or y is 10. So the vertex then becomes, when x is 4, y is 10. I know that it's going to open down. I know I'm going to have a max just because my x squared term happens to be negative. We'll verify with the graph anyway. Domain, it doesn't matter what kind of parabola you have. Domain is always going to be where x equals the real numbers, or the reals. The range, because it's a max, because I'm opening down, this is my highest value. Y is less than or equal to. Well, what is the highest value? It all depends on the coordinate of the vertex, the y coordinate, and that happens to be 10. So algebraically, here's all your stuff. X equals 4, vertex is 4, 10. It's max, it opens down. Domain is always x equals the reals. The range in this case is y is less than or equal to 10. If we go back to the calculator and plug all this stuff in, you go to y equals, clear this out, negative x squared plus 8x minus 6. I'm going to take a look at this graph. There it goes. It opens down. You can probably count over the vertex on your own. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the vertex. You can also actually see the vertex if you go to your table of values. You can see the vertex right here, because on either side of it, things match up equally. I've got the 9 on either side and the 6 on either side. Notice how the numbers on either side of that y value are less than that. And that, again, is also why your range is going to be y is less than or equal to 10. There's that one. Those are the ones that have the most work. When you get the graphs, that's what it makes it should be a lot easier. So this next particular one, next slide. All right, vertex is probably what I'm going to pull out first. Here's my vertex. My vertex is going to be negative 1, 4. It should be pretty obvious that this vertex is a minimum value because the graph opens up. Domain never changes. X equals the reals. All that's left is axis of symmetry and the range. Well, don't forget the axis of symmetry is what the x is. And the fact that the x in this case is going to be this negative 1, the axis of symmetry is x equals negative 1. The range all depends upon the y coordinate. This is our lowest y value. Remember, here's your y-axis. So your y is greater than or equal to 4. Your vertex plays a key role in helping you find axis of symmetry and the range. Let's take a look at the next one. This guy opens down. Here's the vertex, -4, -1. It opens down. It must be a max, which automatically the range has to be y is less than or equal to. And we know what the y coordinate is. It's -1. So in terms of the range, y is less than or equal to -1. Domain we know is always going to be x equals the reals. And then the vertex for the axis symmetry, we know that x is -4 because this is the line of the axis of symmetry and the x value right there is -4. Okay, next one. Below is the graph of y equals x squared plus 4x minus 192. By looking at the graph, what are the roots? The roots are the same thing as the zeros, which are the same thing as the solutions. We'll go by the zeros first, and then we'll talk about solutions. Well, here is a 0. Here is a 0. It's where the graph crosses the x-axis. So one of the roots, as an ordered pair, is -16, 0. The other root as an ordered pair was 12, 0. These right here are your roots. If you wanted to solve this algebraically, not graphically, all you would have to do would be to factor and solve this quadratic equation. And we've done this already. A little bit harder to I-am this, but when you do I-am it, it turns out that you get x plus 16 and x minus 12 equal to 0. But those are the factors, not the roots. How do you find the roots? You draw your wall, you take what's inside the parentheses out, and you solve for x. This solution, x equals -16, x equals 12, are the roots. Because again, this root right here was -16. This root right here was 12. There should be a connection between factoring I-am stuff and looking at the graph. So zeros in graphs are the same thing as roots in graphs, which are just like solutions with I-ams. Okay, next one, multiple choice. Which of the graphs could be used to find the roots of the equations x equals or x minus 5 and x plus 7? So I'm actually going to come over here where there's more room. So x plus 5, x minus 7. So this is your thing that equals to 0. Well, what are the roots? That's pretty easy. All I need to do is drop my wall and solve each factor. Set each factor equal to 0, subtract 5 on both sides, x equals -5, add 7 on both sides, and x equals 7. Well, that would actually let me take a look at this graph right here, which is going to be, hold on here. I did something wrong. Hold on. See if you saw I put these equations incorrectly. I knew why that didn't make sense. X plus 5 is what I wrote. X minus 5 is what it's supposed to be. So let's just fix that. Okay, let's try that again. So the problem shows you x minus 5, sorry about that, and x plus 7. That's what the problem shows you. Let's try this again. Drop my wall. I'm going to set this factor equal to 0 and solve. I'm going to set this factor equal to 0 and solve. So the roots are +5, -7. Well, this graph has a root at +5, -7. This graph has a root at +5, -7. This one doesn't. That's -5, +7. And this one has +5, +7. So all I have to figure out is what is the equation? Do I have a max or a min? And the way to do that would be is to take those two factors and FOIL them. And when I FOIL it out, I can even stop right here because this turns into x squared. That's enough to say x squared is positive. It must be this particular graph because it's a positive x squared value. It must open up. I can finish this though and say plus 7x minus 5x minus 35, which means my y equals equation is x squared plus 2x minus 35. When you FOIL out x minus 5, x plus 7, that's what you get. Let's do a quick calculator real fast. Let's clear this up. Let's go to y equals, clear this out, and let's see. We've got y equals x squared. I feel like I said something wrong again. X squared plus 2x minus 35. I have a feeling I said something wrong again. That's what happens in the afternoon when you get tired. There's a look of your graph where you have your roots over here, and it's a minimum because that's the bottom of your parabola. Let me go back because I think I said something wrong again. Oh no, I didn't. It's all good. Okay, x squared plus 2x minus 35. I thought that I said that wrong. Okay, last but not least. Last but not least. All right, which of the following equations could be solved by identifying the roots shown? So here's kind of where the working backwards game is. You could plug in every single one of these equations and look at the graph to see which one matches. Or what you could do is say, this root is x equals 1. This root is x equals 4. Well, if x equals 1, it must have come from the equation x minus 1 equals 0. If x equals 4, it must have come from the equation x minus 4 equals 0. If I multiply out by FOILing those two equations, I'm going to get x squared minus 5x plus 4 equal to 0. And then I could always double check it to make sure that that's what it looks like. And that's the last thing that we will do. Quick check, y equals, get rid of this, clear it out. Choice C says x squared minus 5x plus 4. Quick graph. Did something wrong. What did I do wrong? Minus 5x, not plus 5x. Keep going. Minus 5x. Does that look better? Sure does. Graph this. And there we go. Here's where we crossed over at positive 1. Here's where we crossed over at positive 4. Okay, so hopefully this is helpful for the review. Tomorrow the quiz, not very long. You got plenty of time, and that's it. All right, have a good night.